great range of properties you find in the world of plastics naturally makes them very popular with designers and manufacturers. These washing machines are using polymers in place of metal, a move which has affected their design in a significant way. The most vital part of a washing machine is the tub which holds the water, and it has a very demanding role to play. It's got to withstand the constantly changing temperatures, the action of detergents and water, and it's got to be capable of mass production. The majority of washing machines on sale have a metal tub similar to this one. The tub has brackets so that it can be mounted into the machine chassis and receive the various pieces which have to be attached to it, pipes, springs, and the motor. It's all very complicated, and the whole assembly process itself is long and painstaking. Metal drums are fabricated from a number of separate pressings. Sheet metal is gradually pressed into the right shape. Holes for the water hoses have to be stamped out of the pressings. Brackets have to be welded into position. All in all, a tub like this one requires 16 separate components which have all been pressed and then welded together. But a metal tub still requires treatment to protect it from the corrosive action of water and detergents. The metal is sprayed with a slurry of minute particles of glass, clay, and water. The tubs are then dried and passed through an oven. The heat, over 800 degrees centigrade, causes the glass to melt and it fuses to the prepared metal surface. The process is called vitreous enameling, and it produces a tough, hard-wearing, protective coating with good chemical resistance. A few years ago, a washing machine manufacturer did some research into the feasibility of using plastic instead of metal to cut down on manufacturing costs. A prototype tub was made which proved that plastics could do the job very well indeed if a few problems could be ironed out. The main drawback was a fault which often occurs when you move from metal to plastic. After testing, cracks were found in these supporting struts. Polymers dislike sharp corners because they lead to concentrations of stress, and stress manifests itself in cracks. The stress occurs from the differential cooling you get when a polymer is formed. This transparent plastic square has been molded from hot plastic entering a die at the top of the picture. As it reached the bottom of the die, it became cooler, and stress built up, which on further cooling was solidified into the square. This bar of molded plastic has internal stresses in it, but they're well distributed. But the same bar molded with a sharp nick in it shows a high degree of stress has built up around the nick. It's the concentration of stress which reduces the toughness of the component. This can be demonstrated with impact testing. Without the nick, the bar breaks at 0.5 joules force. With the nick, the bar breaks at less than 0.1 joules, an 80% reduction in its toughness. The solution? Make the strut curve gently so that the internal stresses are evenly distributed. Crucially important is the bearing supporting the drum. This has to be exactly on center. If the drum is spinning with an unbalanced load of wet washing, it'll tend to deflect and start wobbling. If the deflection becomes too erratic and the drum begins to spin against the side of the tub, it could cause a great deal of damage. In production, the metal bearing support is placed in the mold and the tub is formed round it. This ensures that the tub is formed with the bearing accurately on center. tub is made from a special glass-reinforced polypropylene, but added to this polymer is a foaming agent. As the molten polymer is injected into the mold under pressure, the foaming agent produces bubbles of gas. The polymer foams. This helps fill the mold. But it also produces a honeycomb effect in the cold molding, which provides both strength and lightness. When clothing is spun dry, the tub is subjected to severe centrifugal force, and strength is essential. The polymer also has a very high resistance to fatigue strain, which is a problem for metal drums, especially at the weld joints. The plastic molding includes small cores, bosses, and the brackets for securing motors and pipes. All of them an integral part of the design. These and the holes for the pipes are all formed when the molding is made. This makes things much easier at the final assembly stage. Also, being polymer, it's easy to fit self-tapping screws, which of course speeds up assembly. Water pipes can be connected to the tub in a matter of seconds using rubber grommets and a rubber solution to complete the seal. One disadvantage of this plastic polypropylene is that it's flammable, so the water heater has to have additional fail-safe cutouts to prevent it from overheating and possibly catching fire. Altogether, some 12 components are attached to the tub, which is then suspended in the housing by springs. The sound-damping properties of structural foam polymers make this machine much quieter than ones fitted with metal